Hello children, welcome back to my channel. In the previous video I have completed triangles chapter. Now I am dealing with quadrilaterals. Now there are certain terminologies and certain definitions which you should know children before going to this topic. So I have written it on the board and I'll explain. Please listen to it. Definition of a quadrilateral is a simple closed figure bounded by four line segments in a plane. Simple closed figure. So see, this is a closed figure and which is bounded by four line segments. So what are the elements of a quadrilateral? It has got four sides: AB, BC, CD, DA. Sides are four. Angles: angle A, angle B, angle C, angle D. Four angles. Vertices A, B, C, D are the vertices. Apart from this, if you join A and C, it is one diagonal. If you join B and D, it is another diagonal. So it has two diagonals. So these are the elements of a quadrilateral. And we have at present in your ninth class, up to ninth class, types of quadrilaterals, we have two types. There are many other types also are there, but for your portion, this is quite enough if you learn up to this. So we are going to talk about those two types of quadrilaterals. They are convex quadrilateral and concave quadrilateral. So what is the difference between the convex quadrilateral? This is convex quadrilateral and this is concave quadrilateral. Let me draw a line so that you will have a clear idea about the differences between them. So the differences between convex and concave quadrilaterals are: first point, each interior angle is less than 90 degrees. So if you see this figure A, B, C, D, every angle is less than 90 degrees. It might be an acute angle or an obtuse angle, but it cannot be a straight angle. So you have all the angles are less than 90 degrees. But in concave, one of the interior angles is greater than 180 degrees. So this is the figure you see here. This angle B is having reflex angle. Angle B is a reflex angle and its value is greater than 180 degrees. And two diagonals lie inside the closed figure. So when you join the opposite vertices, the diagonals are inside the figure only, but one diagonal lie outside the shape. See, BD is one diagonal, AC is one diagonal, and AC is outside the given shape. So this is called uh, concave quadrilateral. This is called convex quadrilateral. Please note it down. You should know these differences, children. Now let us find out what is the value of sum of the angles of a quadrilateral. Suppose you have got one quadrilateral A, B, C, D. You want to know what is angle A plus angle B plus angle C plus angle D. So what is given to us? We have got A, B, C, D, a quadrilateral. What we need to find out, required to prove is angle A plus angle B plus angle C plus angle D is how much we have to prove. So proof here, how to find out. First for this you have to join A and A and C. Okay, so let me write it as first construction. Construction is join A and B. So you have to join construction, join A and C. So when you join A and C, now let us see the proof what you have to do. See, you are getting two triangles, triangle ADC and triangle ABC. But when you are talking about this A and A, this is common, we may confuse. So let me name it as 1, this angle as 2, and this angle as 3 and this angle as 4. So angle A plus angle B plus angle C plus angle D is equal to angle A plus angle B plus angle, uh, let me write angle, it is nothing but angle A plus angle B plus angle C plus angle D is equal to sum of angles of triangle ADC plus sum of angles of triangle ABC. So let us see sum of angles of triangle ABC is equal to angle 3 plus angle 4 plus angle B, that is 180 degrees, and sum of angles of triangle ADC is equal to angle 1 plus angle 2 plus angle D, that is 180 degrees. Therefore, angle A plus angle B plus angle C plus angle D is equal to 180 degrees plus 180 degrees, that is 360 degrees. Therefore, sum of angles of a quadrilateral is equal to 360 degrees. So this is a property, children. Sum of the angles of a quadrilateral is 360 degrees is a property that you have derived here. So let us see. Sum of angles of a quadrilateral, I have taken a quadrilateral, I have joined A, B, C, D, I have taken, and this is given. What is given? Quadrilateral A, B, C, D. What is required to prove? What is angle A plus angle B plus angle C plus angle D? Now construction here, what we require is you have to join AC. So when you are joining AC, what are you getting? Two triangles you are getting. So when you are taking triangle ABC, sum of angles are angle A plus angle B plus angle C. If you do like that, you will be confused with this angle A. That is why angle A name is there for both the triangles. That is why I have named the particular triangles values, angles with some numbers. So this is angle 1, angle 2, angle 3, angle 4. So angle A plus angle B plus angle C plus angle D is nothing but sum of angles of triangle ADC plus sum of angles of triangle ABC. So what is sum of angles of triangle ABC? This is ABC. Angle 3 plus angle 4 plus angle B. We know that sum of angles of a triangle is 180 degrees. Already we have proved it in triangle chapter. Next, sum of triangles of ADC, that is angle 1 plus angle 2 plus angle T, that is also 180 degrees. So angle A plus angle B plus angle C plus angle D is 180 plus 180, that is 360 degrees, children. Please note it down. Now we'll talk about different types of quadrilaterals, children. In the bracket I have written convex quadrilaterals because already I have told that there are concave and convex. So in convex we have still more different figures. So one by one we will do. The first one is trapezium. Trapezium, it is, the figure is like this, trapezium. So what are the properties? If you know, you can construct it very easily. One pair of opposite sides are parallel. So in this trapezium, AB is parallel to CD. This will indicate that these are parallel. And non-parallel sides are equal. If non-parallel sides, that means AD and BC are equal, then they are called, that figure or that trapezium is called isosceles trapezium. Next, parallelogram. What is parallelogram? It is a figure which is formed by four sides in which opposite sides. The property here is opposite sides are equal and parallel. See, AB will be equal to DC and AB will be parallel to DC. And opposite angles are equal. Angle A will be equal to angle C, angle B will be equal to angle D. Diagonals bisect each other. So, when you draw the diagonals, AC is one diagonal and BD is one diagonal. This is the point. They bisect each other. That means they divide each other into two equal halves. Each diagonal divides the parallelogram into congruent triangles. So if you talk about AC is dividing it into triangle ABC and triangle ADC. These two triangles are congruent. Or if you talk about BD is dividing this into triangle ABD and triangle BDC. Both are congruent triangles. So each diagonal divides the parallelogram into two congruent triangles and adjacent angles are supplementary. Supplementary means their sum is 180. Angle A plus angle B is 180. Angle B plus angle C is 180. Angle C plus angle D is 180 or angle D plus angle A is 180. These are the properties which we need, children. These properties are very much essential even for the other chapter, that is coordinate geometry. Even in 10th class also, under coordinate geometry, if you know these properties only, you can solve the sums. Now, third one, children. Third one is a closed figure in which opposite sides are equal and parallel, and it maintains an angle 90 degrees with the sides. So this figure is a rectangle. So what are the properties? Opposite sides are equal and parallel, just like that of the parallelogram. But what is the difference between parallelogram and rectangle? Each angle measures 90 degrees. In parallelogram, you don't get it. And diagonals bisect each other. These two diagonals will divide each other into two equal parts. And upon that, another point here is diagonals are equal in measure. Whatever is AC, the same thing is BD. That is those are the properties of rectangle. And rhombus. Rhombus is this kind of figure is called rhombus. And in this figure, what you can understand, opposite sides. AD is parallel to BC, AB is parallel to CD, and opposite angles are equal. Angle A is equal to angle C, angle B is equal to angle D. This property and a part of first property is like parallelogram. Diagonals are perpendicular bisectors. Means for children, when you join a BD and AC, the diagonals will maintain 90 degrees with it. And also whatever is this AD, if I call this point as O, OD is equal to OB and OA is equal to OC. So the diagonals are perpendicular bisectors, and apart from it, another thing is all sides are equal. All sides are equal in measure. In parallelogram, all sides are not equal, and also in the parallelogram, diagonals, of course, they bisect, but they are not perpendicular. So these are the differences that you can observe with the parallelogram, children. Please note it down. These points are very, very important, children. Don't forget them. Now, the other quadrilaterals, children. Square means all sides are equal. Each angle measures 90 degrees. Diagonals are equal and bisect each other. I forgot to draw the diagonals, children. So these diagonals are equal and bisect each other. They are equal in measure and they bisect each other, and diagonals are also perpendicular. So actually diagonals are perpendicular bisectors just like rhombus. But the thing is, in rhombus diagonals are not equal in measure, but in square the diagonals are equal. Just like rectangle, in diagonals also, in a square also diagonals are equal, and just like a rhombus, the diagonals are perpendicular bisectors. Next, kite. This is the figure of kite in which adjacent sides are equal. See, AD is adjacent to CD. So, AD is equal to CD and AB is equal to BC. Adjacent sides are equal. One pair of opposite angles, angle is equal. One pair means this. 1 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 One pair only, opposite angles, opposite angles. One pair of pair. So one pair of opposite angle is equal. Then diagonals diagonals are perpendicular to each other. So these diagonals maintain 90 degrees perpendicular to each other, and longer diagonal bisects the smaller diagonal. So this AD, let me call this point as O. AO is equal to OC. They bisect the smaller diagonal. So these are the various types, six types of quadrilaterals, which are convex quadrilaterals. I have discussed with children with their properties. It's a very, very important for you in the mathematics, children. Please learn it well. This I'm going to conclude my topic. In the next class, I'll be doing the next part.